Okay, welcome members. In today's lesson today we are going to see how do we differentiate exponents. Please don't forget to subscribe to the channel. We have two types of exponents or the categories. Me, I categorize them into two. The e, the exponent, the e of f of x, and then the a where a is a positive integer. So from here, we see that when we integrate e of this, we get the derivative of this function. If this function is linear, we differentiate it, then we get 1 over the derivative of this function, then exponent of the original function, then plus a constant without limits. So in the example we have here, that now if we compare, it's that our f of x, here our f of x is x. When we differentiate it, we get a 1. So meaning that this would be 1 over 1. Then exponent of f of x, which is the same as x, then plus c. So that whenever you integrate this, you get e of x plus a constant. When we come to this, it's that here we have a definite integral, but our f of x is 3x. If we compare, when I differentiate this, I get 3. So meaning that now this would be 1 over the derivative of this function. So when I differentiate this, I get 3. So 1 over 3 exponent 3x from 0 to 1, which will be now 1 over 3. Now I put in the limits. E, when I put in 1, I'll be having 3 into 1, then minus e into 3 into 0. So this will be a third into, this is e power 3 minus 3 times this is 0. So e power 0 is a 1. Anything in the power 0 is 1. And that becomes your answer. So from here, this one is linear. So when I differentiate, now the idea is very easy. Differentiate this and then reciprocal. When you differentiate this, we get 2. So it will be 1 over 2. Then exponent of the original function, which is 2x plus 1. Then from negative 1 to 1. So this will be a half into now exponent. When I put in 1, I have 2 into 1 plus 1, then minus e of 2 into negative 1 plus 1. This will be a half into, this is 2 plus 1, so we have exponent 3, minus this negative 2 plus 1, e of negative 1, and you can evaluate that on the calculator. When you differentiate this, we see our f of x this time is negative 4x. When you differentiate it, we get a negative 4. Meaning that now this will be 1 over negative 4, exponent of the original function, negative 4x. You don't have limits, so you put a constant of integration. This will be now negative 1 over 4, exponent negative 4x plus a c. Now when you come down to category 2 of this type, it's like now this one is a positive integer. What is your a should be a positive integer. So, you see how we differentiate this is that our f of x this time is x. So, we need this. So, my f of x is here is x. F prime of x here becomes a 1. So, now this will be 1 over 1. Then, a, now my a is 5x over natural log of a, which is a 5 plus a constant of integration. So, this one is orange. 5x over natural log of 5 plus c. When I come to this, when I differentiate x, I get 1, so it will be 1 over which is 1, which is 3x now, over natural log of a, which is 3 now plus c, because we don't have limits. When I come to this now, you see, when I differentiate this, I get 3, so 1 over 3 into now, this one to our 3x over natural log of 2. Because our a is 2, then from 0 to 1. These two are constants. You can have 1 over 3 natural log of 2 into now, when I put in 2, I'll be adding into 1, then minus, when I put in the upper limit, then I put in the lower limit, 3 into 0. In this one, I've simplified because this is a constant, multiplies this, you get this. So, this will be 1 over 3 natural log of 2 into 2 power 3, that's 8, minus 2 power 1. You see this one is b 3 times 0, this is 0. Then 2 power 0 is 1. So we have 8 minus 1, which is 7. And now we have our answer becomes 7 over you can give this to 4 decimal places. So that's how we calculate those exponents. I wish you the best.